the word relationship always means more than one item. There can't be a relationship with just one item. There has to be two items or more. In the same way, when we're dealing with angle relationships, I'm going to introduce you to 5 angle relationships, 5 of them, and every single one of them has to do with 2 or more angles, a special bond, a special relationship between them two. Before we identify complementary and supplementary angles, we're going to first write down the definition of adjacent, the third one down. Adjacent angles, ready? Adjacent angles are angles right next to each other. Right next to each other. I mean, you can't get any more simple than that. Right, Mudio? Just putting your phone away? I mean, that's pretty simple. Go ahead and have the floor. I think you'll break a record staying with me the whole summer for 1 credit. It's going to be fun. Angles right next to each other. Let's see. I'm not going to even draw a picture because you have a picture of adjacent angles on your note guide there on the second page. Right in the middle of this, if you flip it over, look at adjacent angles. Flip the page over in the middle. I think it's in the middle. Yeah, actually, yeah. On the top. Top of the second page. Adjacent angle. Look at it. You got a picture of them. Look at angle 5 and angle 6 right here. They're right next to each other. They have a common vertex. Okay, remember the vertex is the corner of the angle? And they share a common side. Notice. Okay, that's what adjacent means. Nothing more, nothing less. This is an example of adjacent angles. So we're not going to draw a picture. You have the picture right in front of you on the note guide. Cool. Let's go back now. Flip the page over. Let's define complementary now. What are complementary angles? Here we go. Perhaps some of you have been introduced to complementary angles prior to my class, and they may remember what those mean. Get it? Thank you. Angles that add to 90 degrees. I'm going to put that. Simple, straightforward, nothing more, nothing less. Complementary angles. Do we have a picture of complementary angles? We sure do. Look at the bottom of your paper. Are you making fun of my writing again?
No. Here. Here.
Angles right next to each other. Complementary angles. Angles that add up to be 90. Look at the bottom of your paper. Look at it. Complementary. The bottom of your paper. Look at the first picture here. Look at angles 1 and 2. You can see the box here from this morning. I taught you what that box means. It's a universal symbol of 90 degrees. You can see that 1 and 2 add up to be 90. Therefore, 1 and 2 are complementary. Look at this picture of complementary angles. They don't have to be next to each other. They can be floating off in space separately. Look at angle A and angle B. If you add angle A up and angle B up, 70 plus 20 degrees is 90 degrees. So these would be 2 angles that are complementary but not adjacent. In other words, not next to each other. 1 and 2 over here would be 2 angles complementary and adjacent. Notice the difference. They both add up to be 90 though, both examples. Question so far? It's a straightforward definition. There's nothing crazy. We've already covered 2. Let's go back to the top. Supplementary angles add up to be what, Ivanovich? Thank you. Supplementary angles are angles that add to 180. Half a circle, in other words. 180 degrees. A full circle is 360 for you skaters out there. 2 revolutions, 720. 3 revolution is 1080. And so on. So half a revolution is 180 degrees.
So what do you think? Adding 360 degrees.
No, I'm not doing that. I'm just telling you what the supplementary angle is.
So like, 360, then 7 and 360, it has the same.
360, 360, 360. Supplementary angles. Go to the bottom of your paper. Look at the supplementary. 3 and 4 are supplementary. Look at, they're right next to each other. And look at, they add up to be 180. Look, it's half a circle. If you add them up, it's 180 degrees. Hence, they're supplementary. How about them? Look at 2 separate angles. Angle C and D, they're floating off in space. They're not connected. They're not adjacent, but they do add up to still be 180. Look at 115 plus 65 is 180 degrees. So that's all supplementary means, is they add up to be 180. A key point, what I want you to underline is put each angle is the supplement of the other for supplementary, and on the complementary put each angle is the complement of the other. So 2 angles add to be 90, I can say one's the complement of the other. If 2 angles add to be supplementary, I can say one is a supplement of the other. Key vocabulary there. Underline that in your note guide. So on the notes now, there's a little section for notes at the bottom. Let's do example 1. Want to put it colder? Okay. Go to example 1. Angle A, write this down. Angle A is a complement of angle B, and measure of angle A equals 36 degrees. Find the measure of angle B. I'll write that down. Bottom of the page, note section. Watch this. So if A is a complement, of B, that means A and B added to be 90. And look at, they gave us the measure of angle A. Remember the little m means the measure? Look at 36 degrees. So find the measure of angle B. Well, if I know that A is a complement of B, I know this to be the case. Watch this. Write this down with me. Let me put this example down here. All right. So I know that A and B are complementary, and I know this is to be the case. Write this with me. Here we go. The measure of angle A plus the measure of angle B equals 90 degrees. I know that to be the case by sheer logic, by this word. I know that to be the case. I know this because I know that word. The word tells me that they have to be 90. Cool. Now let's substitute. Let's plug and chug like I did for a warm-up this morning. What's the measure of angle A here? 36. Measure of angle B, I have no clue, so I'm going to put X for measure of angle B. Equals 90. You got to be kidding. Is Mungia's class really this easy? I can't believe it. I should be ashamed of myself for making this class so easy. How to get X by itself? By? By X is
64.
and X represented, look at the measure of angle B. 54 degrees. We're rocking and rolling. We're done. I should be ashamed of myself for giving you stuff so easy. I'll write example 2. By the way, you could have done this in your head. If you know two angles that have to be 90, you just take 90 minus the one that you know, and it's going to give you the one that you don't know. In other words, a shortcut has just been 90 minus 36. That's 54. That's a little shortcut for you quick thinkers out there who like to do stuff in your head. If you're not, if you're slower like me, write down the equation, rock and roll.
Not making it that easy.
Argument.
It's a long way.
But the shorter way involves higher level thinking that some of us are not used to, like me. That's the thing. So it's for the more quicker students who can do stuff in their mind. In other words, 90 minus 36, I can't do that in my head. Maybe you guys can. Just 54. That's a shortcut. Let's do the example 2. Angle C is a supplement of angle D, and angle D, look at measure angle D is equal to 117 degrees. Find the measure angle C. Someone already did in their head. Someone said 63. Let's see if he's right. What does supplementary mean, though? Soto. Sedona, what does supplementary mean? If C is a supplement of D, what does that mean? Just that word itself, supplement. Say the day, Soto. Thank you, right here. Angles that add up to be 180. So I know just by that sheer word and sheer logical thinking that, watch this, the measure of angle C plus the measure of angle D equals 180 degrees. Just by that word alone tells me everything I need to know. Let's plug and chug. My phone's up. Here we go. Do we know angle C? Do we know what it is? As it stands, we don't. I label it X, or any variable you want. It doesn't have to be X. Angle D, though, is 117. Look at this. Equals 180. Very nice. Is it 63? What's 90? What is? Let's get X by itself. From both sides, exactly. X is, I have no clue. I can't do that in my head. What do you think I am? I'm just a math teacher. Right? So Yanovich was right. Again, the shortcut, if you're a quick thinker, you could do stuff in your mind. Take 180 and minus the one you know. So 180 minus 117 is going to give us what's left over, 63. You could have done that in your head. I just did all the steps for those of us who are slow. Can't do that. Think that quickly, like me. We're rocking and rolling. We got 3 words under our belt. We got 2 to go now. Here we go. Let's go back to the top of the page. The next word is, ready? Linear pair. So remember, these are relationships. Every single word we've defined so far is a relationship between 2 or more angles. Now look at this, a linear pair. Here's another relationship. Write this down. 2 angles, or put 2 adjacent angles that are supplementary whose non-common sides form a line. Form a line. Let me write that down. So if you flip the second page all the way at the bottom, we have a picture of linear pairs. Now when I think of the word pair, I think of two. A pair of shoes, pair of pants, it's always in twos. So look at this linear pair here. Okay? It's two angles. They're adjacent. Notice they're right next to each other. They're non-common sides. So this angle and this angle, the sides that they don't have in common are right here. Look at it. It's on your paper. Non-common side here, non-common side here. They form a line. Hence the word linear. The word linear has the word line in it. It's a pair of angles. Linear pair, they always add up to be 180. They're always supplementary, and you can actually see it. That's actually simply logic. Look at half a circle. It's 180 degrees. They're always going to be 180. They're always going to be supplementary. That's a linear pair. And last but not least, the last relationship is vertical angles. We're done. Okay, vertical angles, here we go. I'll put this one in blue. The Dodgers are going to win, right, Murillo?
No.
Two angles that are formed by two intersecting lines they are always congruent. They are always congruent. Remember yesterday I talked about congruent. Two angles that are congruent have the same measure. They're the same size. You with me, man? Yeah. All right. Okay. Two angles that are formed by two intersecting lines, they are always congruent. Okay, let's see how linear or vertical angles look. Flip the page all the way at the bottom next to linear pair. If you flip it, look at vertical angles. Look at the picture here. Look what it says. 3 and 6 are vertical. Look at 3 and 6 are vertical. I'm going to put a little arc here with a hash mark. That communicates they're the same size. 3 and 6 are the same size. And look at there's two intersecting lines. And look at this. 4 and 5 are also vertical. Go to put an arc here on 4 and 5 and put a double hash mark. Whenever you see the same amount of hash marks, that communicates that those angles are the same measure, the same degrees. Go ahead and add that to your picture there. So those are vertical angles. They're formed when two lines intersect. It's kind of like scissors. You can see the vertical angles formed by my arms. No matter how I move these arms, this angle and this angle are always going to be the same, and then these two are always going to be the same. Do I look funny doing that?
No, it's just really.
Ready? Here we go. So we got those two example 3. Underneath the adjacent angles picture at the bottom, no, actually on the top of page 2, there's a little section for your notes. Go ahead and write example 3. Go and draw this picture. I agree. So underneath the adjacent, so page 2 in the note section for underneath adjacent, go ahead and draw this picture. I'm going to write solve for x. That's the mission. All right. Are these angles adjacent? Are the two angles that you see, are they adjacent? Argument, Munoz. Perfect argument. Say it one more time, because why? They're next to each other. So angle BAC, that's that angle, and angle ACD, ACDC? Does anybody like ACDC? Pretty good band, 80s. Australian band, rock band. I'm sorry? No, we're in 2018, to be correct. Murillo, amigo. Well, we go way back, maybe Murillo. All right, the green and the black angle are adjacent because exactly the reason why Munoz said they're right next to each other. Our mission is to solve for x. That means we have to create an equation. Whenever you have a solve for a variable, that means you have to set up an equation of some sort. So I'm looking at this picture and I'm trying to figure out an equation I can set up. Soto, save the day.
Can I save all the boring colors? That's what I'm saying. That's how I'm going to do it.
I want you to save the day. So that's all.
10x plus 2
Uh-oh. Hit it.
plus 7x plus 8.
Uh-oh. You're adding these puppies. Why?
It's 90 degrees.
Look at, they got the 90-degree square. That means both angles are what? What's a fancy schmancy word for that? Extra stamp, you can get it to me. Compliment, okay, so stamp for you two. You already have too many.
Wow.
You already had 110%. I'll save one though for you later. What happened? Someone give Murillo a hug. So complementary equals 90. That's what the box means. So we're going to set up exactly the equation that Mr. Soto set up, and we're going to go to break. Here we go. 10x, check this out. 10x plus 22, that's the first adjacent angle. No, I'm bringing it down here because I'm running out of room. The first adjacent angle, 10x plus 22, plus the second one is 7x plus 34, equals the whole thing, 90 degrees. This is kind of what we did on warm-up. This is similar. Hit it, Ramirez. What? 17x, huh?
22 plus 34 is 56.
56?
Yeah, 56.
You sure?
Yes.
Positive.
Yes.
Put that on everything. On everything you love.
Moped.
Then that means it's not serious. That means you're lying. You don't like my moped.
I do like your moped.
7 plus 56 equals 90. $17x is, I have no clue. But 34? Nice. 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 Take out your stamp sheet. I'm going to stamp you. We'll go to break. I got you.
Wow.
So with that, we'll talk. We'll talk. So linear pairs, vertical angles. Let's do a few examples here. Okay. This is actually just like warm-up. We just finished one that's almost a replica of this. Notice these two angles, this angle and this angle, their non-common sides form a line, the word line. And you can actually see, look at this is 180 degrees. If you add these two angles up, it's half a circle. So this is a linear pair relationship. They're always supplementary. So we're going to set up the same kind of equation that Soto just did a little while ago. These two angles add up to be 180. So let's set up the equation and we'll be able to solve for x. Here we go. 6x minus 5 plus the other angle is 12x plus 5. They both add up to be 180. Hit it. Go for it. We've got two quick, this example, one more example, and I'll put the game on. So let's do this. Like terms time, 6x and 12x make 18x. Negative 5 plus a 5, that cancels each other out. That's 0. So I got 18x equals 180. Let's get x alone. Divide by 18. X is 10. Done. Questions? Last but definitely not least, example 5, same note section. Put example 5 here. Draw the situation there. Excuse me? Yeah.
So where do we put that?
I like how you're thinking. Hold on, hold that thought. Because people still write it down.
Where do we write that?
I already told you where. 3 times. It's at the bottom of the second page. Everything's linear pair. You got plenty of room. I see kind of the white area. Stop it. Example 5. I have a situation here where two lines are intersecting. Out of the 5 relationships I showed you, one of them is involved with 2 lines intersecting. What's the name of them? Hit it. Vertical angles. Vertical angles are always congruent. In other words, this angle and this angle, look at, there's 2 intersecting lines. These 2 are the same measure. Hence, I can form an appropriate equation. They're equal, in other words. So degrees are equal. So check this out. 64 equals 48 plus x. You got to be kidding me. It's literally that easy. At this point, just get x by itself. What do I do, the casas? What do I do to get x by itself?
You subtract 48.
Thank you. Both sides. By x is alone. Sure. I trust you. X is 16.
What's that for?
We'll see. Hold on.